This is All Things ANSYS, a podcast from the technical support staff at PADT. Episode 127, we chat about taking simulation results into virtual reality and catch up on news and events in the world of ANSYS. Greetings and welcome to our little podcast. My name's Eric Miller, your host for these audio excursions, and we'd really like to thank you for downloading the podcast and giving it a listen. We've still been very busy with lots of activity here at PDT, so we've not been as regular as we'd like to, so apologies for that. In fact, I wanted to share with you one of the reasons why we have been so busy. Retirements. 2024 marks PDT's 30th year in business, which is really hard to believe. And one of the side effects of being around and being stable for so long is people are starting to retire. I'm still working to get my head around that because in my mind, we are still a new scrappy company. But 3 decades is a long time, and people who I still think of as in their 30s and 40s are in their 60s or even older. Time is far more relative to our perception of people than when we get into the reference, into Einstein's math. No one here is moving anywhere near the speed of light. We are all in the same frame of reference, yet this realization that our long-term employees are moving on to a new chapter of their lives is a bit eye-opening for me, which gets me to thinking about how ANSYS has changed. Here we are looking at an acquisition of ANSYS for $35 billion. They went public a few years after PADT started. We started in 1994. ANSYS did their IPO in 1996, and they did it for $13 per share, or with all the splits that have happened since then, the equivalent of $3.25. The acquisition is at $390.19. So to do the math for you, a $10,000 investment at the IPO back in, 1996, will be worth $1.2 million if the deal goes through as proposed with the dollar amounts proposed. Note, I didn't invest. Never, ever take stock advice from me. But back then there was one program, ANSYS. That was what the company wasn't called that. It was called Swanson Analysis Services, I think. The program was called ANSYS. And it had structural, thermal, CFD. Anybody out there remember Flowtran? That was embedded inside the code. And both low and high frequency EMAG built into it. It was a true multiphysics solver from the ground up, finite element across the board. They had not started their own acquisition journey yet. That would begin with ISM CFD in 2000 and really gain steam when they purchased Fluent in 2006 and Ansoft in 2008, creating the 3 core solvers that would drive the growth and success of the company for a very long time. But again, never take investment advice from me because I thought that was good enough. And why on earth would they buy Apache Design Solutions? So they did that. They bought Apache Design Solutions, and which was a set of semiconductor chip simulation tools. And that is what catapulted the company towards this acquisition by Synopsys, a giant electronic design automation company. So, what an amazing journey it has been for PDT, and I've been so happy to be part of it. Be part of this whole ANSYS journey. It's not over yet. I can't wait to see what happens next. It's pretty exciting. But it does seem like yesterday that we were chatting with John Swanson and other key leaders in the pre-IPO company about the same things we talk about today, how our mutual customers get more value from their investment in this fantastic software. And all the changes over the years, that one part has stayed the same, a commitment to creating or adding tools engineers need to drive more of their designs with better information. It's a pretty remarkable journey, even though it seems like a short time. It's been a long time. This software in the company has come so incredibly far. It's just kind of mind-boggling when you really think about it. So I could spend the whole podcast waxing on about the past. I just turned 60, and I do believe that along with that milestone birthday comes the right to bore others with musings on the past. But I will spare all of you and keep moving forward here. Instead, let's look forward. Blockchain was starting to fade just before OpenAI sucked all the oxygen out of the room. And when that was happening, when blockchain was fading and right before OpenAI, the real big focus of technology companies was on the growth of virtual reality and how their tools would fit into it. Well, VR, virtual reality, and augmented reality, AR, didn't go away anywhere. And the power of collaboration in a virtual environment or overlaying the virtual on reality has not gone away as well. That got driven home to me, even though we all got distracted by AI. But it got driven home when I met the team at a company called SciVista at a conference in New Mexico a while back. If the folks at Facebook are trying to create a consumer VR platform, with their whole meta thing, SciVista is well along the way in creating an engineering VR platform that is easy to use and powerful. But I'm getting ahead of myself. Let's hear from them about what they're up to and how it fits into our world of simulation with Ansys. Welcome, everybody. We've got a little bit of a different discussion today. We're going to step out of the direct world of Ansys and talk about something that I find very interesting, and I hope you will as well, which is the use of emerging virtual reality technology for visualization of the engineering work we do. And what got me sparked, the interest in this, is when I met some folks from a company called SciVista who are doing work in that area. And I've asked them to come and join us on the podcast today to talk about what they've been up to, kind of what it means, what they think about it. And so we all learn a little bit about maybe moving beyond our screens into a 3D world to look at our simulations and more. So I want to welcome Mike Langone and Aaron Lau today. Mike, why don't you kick it off by kind of introducing yourself and telling us a little bit about SciVista, and then Aaron, you can introduce yourself as well.
Sure. My name's Mike. I am the CEO at SciVista. Aaron and I are some of the original founders of the company. We go back to 2018. We're in Santa Fe, New Mexico, and the name comes from as Eric was saying, visualization. So we started with a couple of SBIRs from the DOE and created a visualization platform. And what we like to think is, you might go into your kids' room and find a headset, but we like to steal them out of the kids' room and we like to bring them into the real world. We believe it's a really, really helpful tool. And maybe we're a little bit at the front end of the technology, but we've been able to really, with the collaboration we can do with the platform, the immersion experience, bringing in different data sets and combining them with each other. So when we met Eric, we were very excited by the products that he works with, all the simulations and the different data sets. So that's where our interest came in, chasing Eric around and see if we could get on this podcast. Yeah, great. Aaron, what about yourself?
Yeah, I can't believe it's been that long already, since 2018. Right? Yeah,
I know. This has gone fast.
Time flies. Yeah, no. Mike covered the bulk of it, and I just want to add that when you can see this kind of simulation combined with model data in virtual reality, it really helps you get a sense of what you're looking at on a scale and level of intuition that it takes a much longer time to build up if you're looking at 2D screen projections, or even just like X, Y, and Z planar views of something. You can actually hold it in your hand. You hop on, you put on the headset, and you're staring at your hands, but they're virtual, and you can hold this object, you can turn it over, and you can even change its size and scale so that you can see something as small as a serial number, or if you're holding a model of an entire city, you can shrink that down so it fits inside the palm of your hand.
That's really, really cool. So let's I assume that everybody knows what virtual reality is, but I think, as Mike pointed out, we kind of think of it as, hooked up to the gaming console, right? So maybe kind of a more of an academic definition, if one of you could provide what is officially virtual reality?
That's a great place to start. The general premise is that you have this headset that has two different unique screens, one for each eye. And each screen has a very similar but slightly different view of a 3D world, where they're offset from each other by an ocular distance. And it creates the illusion of depth when one eye is looking at one screen and the other eye is looking at the other screen. Your brain will actually take these two images like it works in the real world, and you will perceive that as real depth.
The other thing we find really interesting is there's so many things in science that you can't see in the real world. We did a lot of work developing the product with fusion scientists, and the
Okay.
fact that they could bring plasma into a 3D model and see what was going on. That's the fun part about virtual reality, because some of the stuff you see in virtual reality you'll never see in real reality, if you will.
That's right. Some things are just not visible to us.
That's a really good point. And something that we've always pushed with simulation is that, we can create this visualization of what's going on from a physics standpoint in your product. And here's your 2D image of it. So what excited me about what you guys are doing, and I played with stereoscopic and headsets in the past, but what was the struggle for me is it was me looking at my model, which was just useful. What excited me about yours, and I'd like you to talk a little bit more about, is it seems like your platform makes it easy to import data from a lot of different sources, three-dimensional data from a lot of different sources, and then also collaborate. So could you talk a little bit more about that and what your experience has been with that and using it with your customers?
Yeah, so our platform is called Summit VR, and the premise of it is, like you said, a collaborative virtual space where you can use one of our hundreds of different file readers to bring in data from your computer, and you can bring it into this session. And when you're in there with someone, you're totally synced up. I could hand you this model, could hand it back and forth, and it has the ability to align different data sets from multiple disciplines of like simulation or modeling, all that. So with our readers and our peer review module, you can bring in like this engine block or this coil, and then you can load in the electric fields that are in some sort of VTK file, and you can have those overlaid on top of each other, and you can be editing the parameters in real time. If it has time steps, you could be playing that animation, and you'll be seeing this simulation evolve in the model in real time with someone else, and you can be across the world from them. You're over the internet. You could have scientists and engineers connecting from all the different continents.
The web-based implementation is really neat. I was doing a demo in Massachusetts, and one of my colleagues from the UK popped in the same demo at the same time, and it was just fun to be able to do that. But we have web-based, which is really good for collaboration in this new world where people aren't always with each other, and we're all learning how to do things more remotely. But at the same time, for some of the national labs here in New Mexico, we've done a on-prem implementation. We can put it on a dedicated server that has no access, but it only has access from within the group. So the collaboration could be as controlled as it needs to be on-prem, or it can be anybody can go on our website and download, get running on the launcher today. So it's available in both those avenues, and we've found a lot of interest in both of those ways of presenting it to clients.
Good. Yeah, and what's, like I said, what's nice about it is that it's a neutral platform, and it supporting the VTK files, which most ANSYS solvers will output to in one way or another, seems to work quite well. And something else that I really want to play with, and I haven't had time yet, is this idea of looking at simulation within the context of the product that it sits inside, right? So we tend to look at, say, I don't know, let's say a structural member on a bridge by itself, but what if we looked at it, superimposed on top of a scan of the actual bridge, or a CAD model of the actual bridge, and the mountains around it, and the sky and the sea, and I think it'd just be really powerful. I don't know if you've got some customer examples you can talk about where you've done these kind of real world visualizations for folks.
No, absolutely. One time we went up to Spokane for an APS conference, and we went up there with this group from Langone who had these targets for a type of fusion that they were trying to research, and these targets would be where they would shine really intense, really focused lasers to try and compress down a bit of matter, and that would spark the fusion. But these targets are really tiny. So they had these CAD models of them, and they had some data associated with them. So with the power of VR, we were able to make an interactive demo where we had this target model, blown up to the size that you could hold it in your hand and see it, much larger than it would be in real life, along with the data on top of that. So someone could get a much faster sense of familiarity, and they would learn the topic really, really quick when you can hold it, play with it, see it, and also talk to someone about it.
It reminds me of something that when I used to train people in 3D simulation, back when 3D simulation was a new thing, there were some people that just couldn't literally get their head around 3D geometry looking at it on a computer screen, even if you can spin it around, right? And so this could open the door for a lot of folks that really struggle with that 3D visualization. And just thought of that right now.
Absolutely. I think one of the collaborators we were working with for this APS conference said that they valued 3D so much that their default go-to for visualizing how these lasers would all kind of meet up in the center at the target was they had a clear inflatable beach ball, and they would just take a dry erase marker and kind of like circle the areas where the lasers would go in, and you'd have to use your imagination for the rest. But now you don't have to. You don't have to use your imagination. You can have the model sitting there.
And be inside of it, right? Yeah.
Be inside of it, yeah.
That's really powerful. I think something to be experienced to understand, yeah.
Yeah, and that independent scaling that I think Aaron mentioned a little while ago, depending on what you're interested, you can go in there and scale it, where the other folks who might be in the same session could be looking at it at a different level. You can pull it up for your view while other people are in there looking at their view. I might want to get really deep and down into something where Aaron might be looking at it from a sky view down to it. So there's a lot of fun things you can do there. And we've done a lot of demos with the labs, and we've also done demos with done some coursework with the universities, and everybody comes out of it. We get 80 to 90%. That was different. That was more powerful than not doing it in VR. And that's pretty good to get 80, 90% as survey results pretty regularly. But it's new for people. So some people don't want to put on the headset. That's why we've developed a desktop mode. So you don't have to be in the headset. You could be 2 or 3 people collaborating in headsets, but somebody else could be watching on a desktop and not have to take that big leap into going into the headset.
Yeah, it's really an important distinction because you're delivering to a couple things is the collaboration environment as well as the 3D visualization, but you can have the collaboration if you don't want, you can still have it if you don't want the full 3D visualization in that virtual environment.
Exactly.
Yeah. So, we're the problem with podcasts is it's all audible. So we're talk about, the power of 3D visualization. We're down in words here. If I remember, your website has some pretty good examples of what the technology looks like. What is the best place to go on the web to see what you guys are doing?
To get to the platform itself, you'd want to go to summitvr.app. And then our larger organization website is SciVista.com.
So you can poke around both of them and find it there.
That's right.
Yeah, I highly recommend it. If we piqued listeners' interest in what this looks like, my original goal when I first met you guys, and I apologize, was I was going to play with it and write a blog article and do a video and share it. And I haven't had time. So I wanted to get you on the podcast so you can talk about it and get people interested instead of waiting for me. And hopefully they'll have more time. Listeners will have more time to get in there and dig around and understand a little bit better. I'll definitely put these in the notes for the podcast. Anything else you want to share with our listeners that you think they should know about VR in general or your application in particular?
No, I think, when we met and you were giving a presentation on digital twinning,
yes,
and all the assets that are available to the ANSYS user, that's really what got my interest, Eric, was the ability to share a different way for all these folks that are using what I understand is a very great program in the industry to visualize it differently. That's really what we're bringing to the table: a visualization opportunity, collaborative, immersive. But that's I'd love people to either contact us or check our website. We've got a connect form on the website, so they can reach us that way as well.
Great. Yeah. And it's, I think that those of us that have played with this technology in the past have literally played with technology that's built more for the entertainment world. Like a friend of mine's got a platform to do virtual fashion shows, which is pretty neat. But I was left going, that was cool, but how is that going to help my life? And then I saw this, and I'm like, oh, now I get it. So this is how it could really make a difference in the way we do work here and collaborate with customers here. And we hope to find the time to integrate it more into our processes as time goes by, and work with some of our remote customers around the world and get them to get a chance to see how powerful it is as well with both our CAD models. We talked today about simulation, but PADT does a lot of CAD as well. So that's got a big potential. We've got a complicated project coming up that I hope to be able to convince my team to dig in on. So cool. Well, I appreciate your time and your patience on this whole project, and hopefully we'll move it forward a little bit quicker in the coming months. But do everybody reach out to these folks at summitvr.app or SciVista.com and check it out. And as always, reach out to us or directly to them if you have any questions or comments. And hopefully we'll get some folks meeting up in the virtual world soon.
Sure. Thank you. Thank you for the opportunity, Eric.
Thank you so much, Eric.
Thank you. I really appreciate your time.
As I said in the intro, I've been busy and have not had the time to dig into this technology like I wanted to, but some of our engineers have checked it out and are confirming how easy it is to implement the tool and import results and share them both in the fully immersed version of the tool where you're wearing the goggles and everything, or in the 2D view of that 3D world through a web browser. So after re-listening to this interview, I was reminded of what a pain it used to be to set up a projector in a meeting room. I don't know if those of you have been long enough to remember, you're going to show your ANSYS results. You had to go to the meeting room, you had to hook up your computer, pull up ANSYS, share your results. It was a real pain in the butt. All of that is simplified with this platform. We don't have to go to a real meeting room at our desks, just like we share a screen in Teams or Zoom. We can take our results into this virtual world and view it. It's pretty cool. So anyway, check out their website to learn more. And, I think people will find it quite useful. So for our commercial, I want to talk about training with PADT. We still deliver a noticeable amount of custom training to folks. Yes, you can use the ANSYS online training, and we highly recommend that you always start there with your training needs. But more and more of our customers are finding custom training led by the very people you hear from this podcast as a great way to improve their skills. We do it over Microsoft Teams or WebEx if you prefer a secure connection, and you get the benefit of interacting with live instructors and they answer your questions, and there's discussions, and it's a lot better than just going through a tutorial. Our customers feel they learn more, get up to speed faster, and avoid issues and mistakes because of the interaction that they get in the class. So reach out today to swsupport@padtinc.com or give us a call at 480-813-4884 and ask about training. It's an investment that you will not regret. Okay, so let's move on and take a look at the stock price. So I'm recording this from Tucson, Arizona, a hotel down here in Tucson. I was at a conference today on MedTech on May 21st. And when I looked earlier today, it was $326.76 a share. It moves up and down a little bit, but remains pretty flat since the acquisition announcement. What interests me is how it is trading below the announced purchase price of $390. So I don't really get Wall Street. I imagine that it would be around $390, but it's not. ANSYS did release their Q1 results for 2024. The key points in that press release are that revenue was $466.6 million, which is actually down from $509 million for Q1 versus Q1 in 2023. There was actually kind of noticeable drop in profit from $100 million in 2023 to $35 million in 2024, and that took their margin from 25% to 9.3%. So it'll be interesting to see if that's made up for in other quarters. There were some cool statistics in the press release that I'll share. I'm always kind of interested in where the revenue is coming from. So 44.7% was in the Americas, mostly North America. 25.4% was in Europe, Middle East, and Africa, with most of that being in Europe. And 29.9% was from the Asia Pacific region. So, the U.S. is not quite 50% of that revenue. And the Asia Pacific is kind of recovering from a little bit of a lull during COVID. So cash sits at $1 billion, and long-term debt is $754. So about $250 million is the difference there. So they got a lot of dry powder, though, with $1 billion. That's where they sit financially. The only news about the acquisition is that a few days ago, I think it was about 5 days ago, China's regulators had flagged the acquisition. They said that they needed to evaluate it. I didn't quite understand it because the merger is below the threshold that requires approval in China. So I suspect that they're making noise for some political reason. Who knows what's going on there? But that's the only news around the acquisition that we've heard out there. And as I mentioned before on the podcast, no one in ANSYS talks about the acquisition. It's all because of the whole Wall Street thing. There's no taboo subject. So I don't know what's going on. In other ANSYS news, in an indication of why Synopsys is actually interested in buying ANSYS, TSMC certified another application of ANSYS, the modeling for HPC and AI chips that are made in the TSMC foundries, using the ANSYS tool set to simulate those chips before you go into production. So this is what it's all about, right? These are very large acquisitions of software that support the design of these chips and simulation of these chips. So the only other news since the last podcast was that ANSYS partnered with a company called Schrodinger to optimize material selection. And I'll avoid the Schrodinger cat jokes and just kind of move forward, as much as it's tempting to go and talk about it. The press release kind of summarizes it. So I'll just read the 2 points at the top of the press release. ANSYS and Schrodinger, and they do use the umlaut over the O, so Schrodinger, are collaborating to develop an integrated computational materials engineering, ICME, approach to product development that infuses virtual materials discovery into the early stages of design. And then they state the predictive accuracy of ANSYS multiphysics solutions combined with Schrodinger's material solutions help engineers identify suitable materials for their designs before manufacturing begins. So it's basically a tool that optimizes your material choices. It's kind of cool. Do check out that press release if you want to learn more about it, if that's something of interest to you. So I think it's going to be an interesting, see how that progresses. In PADT news, we don't have any this month. Nothing too exciting going on. I will mention two things that are not news, but worth noting. And I mentioned this before, but it is our 30th anniversary. And if you are in Arizona in October, please save the date to come by our open house. We call that open house Nerdtoberfest, and it's on October 23rd this year. It's a big open house where we invite customers and partners and everybody else in the community here in Arizona. And because it's our 30th anniversary, we'll be inviting many of our partners from the products we sell or out-of-state folks, and it'll be a big party. So combined 30th anniversary and PADT Nerdtoberfest on October 23rd. So do check that out. If you want to learn more or even get yourself on a list to make sure you get an invitation, go to padtinc.com/PADT30 or padtinc.com/Nerdtoberfest to learn more. Or if you actually just go to our homepage and click on the big PADT30 logo, you'll find it. So let's talk about ANSYS blogged posts. The one that I really want people to take a look at, I have to really think about it because it's really kind of important. And everybody's talking about AI and how AI is going to change the world. Well, ANSYS has come out with a few AI products, and we might do a podcast coming up on once the things have stabilized a little bit on what those are. But one that's really important and you need to pay attention to is called SimAI. And they did a new blog post called Explaining SimAI, How AI is Applied to Numerical Simulation and Practice. And it's a must read to get your head around around how we can use this technology to do stuff. It's kind of jaw-dropping to see what it does. Kind of like, when you listen to when you ask a question to ChatGPT for the first time and you're like, oh my gosh, this is kind of like that. I'm not going to spoil it, what's in there. You may have seen the video that came out. I recommend everybody check it out. Even if you're not really interested in AI, you need to check it out. Another big area of interest for us here at PADT is using simulation to verify and validate medical devices. In fact, I was just at a med device conference here in Tucson, and we talked about this very topic of how to use do what's called in silico, and so on the chip simulation to do verification and validation of medical devices. And it's a really good example. The article is called "Democratizing in Silico Medical Device Testing." So check that out if you do medical device stuff. A little less cool, but probably actually the most important thing we're going to talk about is an article called Understanding Data Security for Ansys Cloud Workloads. So we're doing more and more of our simulation in the cloud here at PADT. I know many of our customers are as well. And we really need to make sure we understand security because it's a really important part of making that move to doing more simulation in the cloud. Even if you're just doing bursts like we do, when we run out of capacity, we'll run over there. So check it out. It's a really good article. So all of this, those articles and more are available at ansys.com/blog. So on our blog, we have 2 articles of note. Our very own Tyler Button just put out a post on using Ansys Maxwell to model something called a twisted Litz wire. And if you don't know what that is, join me. I don't know. Didn't know what it was until I read the article. But it's basically when you take strands of copper, right, in a wire and a cable, and you twist it. You don't want to model each and every one of those strands, right? So the problem is, though, how much longer is the wire when you twist it versus when it's perfectly straight? And that's what they're talking about in this twisted Litz wire. So it's a great example of what I was talking about at the beginning of the podcast. Developers adding a clever little feature. In this case, how that wire length changes when you twist it into a cable to help engineers get better information with less effort. So very useful little tweak, but mathematically probably not that simple. But they got it working. And he did a great article on how to use it. And then I just published an article called "For Newish Text Functions in Microsoft Excel That Every Engineer Should Know." I know it's not Ansys, right? It's Excel. But let's be honest, we all use Microsoft Excel to pre and post process so much of our data that we use in simulation. And I've always been very frustrated by how hard it is to parse a string in Excel. Well, that's no longer true. Check out the article to learn more. They've got a couple functions that make it really easy to split up those strings. So our blog is at padtinc.com/blog, and those 2 articles are there, along with all sorts of other useful information and older posts from many, many years that we've been doing that. So do check that out. So let me pop on over to said website and check out our events. So we've got some webinars coming up. This is going to probably be, that one's after the podcast will come out. But on June 26th, we've got one called Structures Update in Ansys 2024 R1. This is the 3rd of our Structures Updates in our seminar series. This one's going to focus on materials, contact, and joint elements. So check that one out. And then on June 26th. And then on July 10th, we're doing Fluids Updates in Ansys 2024 R1. We're going to take a look at some of the kind of accessory products that work with Ansys Fluids. Nsight, the pre and post processor, ChemKen for doing chemical relation stuff, Forte for combustion, and then the whole CFX and turbo tools for rotating machinery. So again, that's July 10th. And then what other events is PADT doing? Well, the next one coming up is going to be in Arizona, the E-Mobility Clean Energy Summit on June 27th, up in Phoenix at SkySong Building 3, and we're going to take a look at the growing electric vehicle and battery industry in Arizona and talk about all sorts of stuff there. And I'll be leading up a discussion as well as part of that. Going out a little bit, but just in case folks are in New Mexico listening, I'll be at the New Mexico Tech Summit on September 10th. I recommend you check that out. It's a great event. And as we mentioned earlier, you got to come to our Nerdtoberfest on October 23rd in Phoenix, in Tempe, Arizona. So those are the events we got coming up. And that's pretty much it. So I want to thank everybody, as always, for downloading and listening to our podcast. We really do appreciate it. Don't forget to subscribe to our newsletter at www.padtinc.com/opt-in and subscribe to the podcast wherever you subscribe to your podcasts. Do spread the word, let other people know about it. And as always, don't hesitate to reach out. Thank you for joining us for the All Things ANSYS podcast, episode 127. As a reminder, this podcast is not affiliated in any way with ANSYS Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.